In this video, we are going to look at a way to create a 60/40 data partition. And we're going to use the famous dataset iris, which is built into R, so you don't need to go grabbing this dataset from anywhere externally. We're going to use dplyr, which is the package that contains some of these slice verbs, or these slice methods or functions that you see here in the source pane. So when we do a data partition, we have to think about random selection of observations that will be sent either to training or validation. And the reason why that's so important, to really show why that's important, I'm going to actually just look at iris. I'm going to look at this data set. And I want to make sure I see all of iris together. And so there it is. It's rendered down in my console. And I'm going to scroll through. And as I do that, what I want you to notice is that the observations in this data set are arranged in a certain way. So the way this data set works, there's 150 observations, and the first 50 are all the species Setosa, the next 50 are all versicolor, and the final 50 are all virginica. So that's why we can't simply just go in and take the top 60% to build the model and then test that against the bottom 40%. If we did that, we'd be basically building the model with two of the species and then testing the model against a few rows from one of those species, but then mostly against a species that was completely not used in the building of the model. So we don't want to do that. We want to always make sure that when we create a data partition, we're using some randomness along the way in terms of the selection of which rows go where. And I'm going to run this line that you see here on line 6, this code set seed 699. That is going to give us reproducibility. All it means is that if you ran the same code the same way, you would see the same rows being sent both to training and validation. And that is not a requirement of doing a data partition, but I did it here so that you would see the same thing if you replicated this. Okay, so what I'm going to do is call this slice sample function here. So we're going to run line 11. So I've clicked down, my cursor is right there. I'm going to give this a little control enter, and then boom, now scrambled iris exists. Let's take a look at scrambled iris. And what I want you to mostly focus on is the last column, which is the species. And so in scrambled iris, all the species are all mixed up every which way. We've got virginicas, we've got versicolors, we've got setosas. They're all just all over the place. And that is lovely and good and wonderful because it means that the whole thing has been shaken up and put back together. And as far as the code goes, slice sample is what did that. The first thing we pass to slice sample is the data frame that we want to do this to, and that's iris. And the next thing, we could give it either an n value or a proportion value. By saying prop equals 1, it just means let's just use the whole data set. So that'll work. It doesn't matter how many rows are in your data set. That prop equals 1 is going to work no matter what, because you're just saying I'll use everything. And what's really happening here is it's sampling without replacement. So of those 150 rows, you could sort of imagine there's like a hat, and the hat starts empty, and the rows get randomly picked and then dropped into the hat. And so even though they're all coming back into the hat, they're coming back in a random order, and that's what we see here with scrambled iris. So the last two steps are actually really straightforward. We can use slice head, and that's just going to take the top 60% of rows right off. So I'll run that here, and there it is. And because the randomness already occurred, now we can simply cut. So we're going to slice the top 60% off. That's going to become the training set. And then we'll slice the bottom 40% off with slice tail, and that will become the validation set. And so a couple other ways we could have done it. We could have used a pipe operator, but it really wouldn't have saved us anything. The code would look very similar, but we would just be piping in iris in the first example and then scrambled iris in the last two. And there's many ways you can do a data partition. There's a lot of other functions in R for it. But ultimately, the thing that they have in common is that they're going to involve that randomness in terms of the selection of rows that go into either training or validation. And then also there's another thing I should mention that's listed up here, which is that we don't want to have any overlap. So we don't want to do any kind of sampling with replacement, where we can end up with the same observations in both training and validation. Those two sets should be disjoint, which really just means they shouldn't have any rows in common. Okay, well, thank you very much for watching, and that is a data partition with a slice family of verbs from dplyr.